In this part of the video series, we're going to examine how to solve quadratic equations by factoring first. We've already looked at how to solve when our quadratics are in factored form. So in this part of the series, we're going to get the quadratic equations in factored form and then solve. Now, the bottom line, in order to solve quadratic equations in factored form, and we saw this in the previous video, is they have to be equal to 0. You need to make sure you set it equal to 0. And we saw in the previous video the reason why is you're going to have two factors. I'll refer to them as A times B. Either 2 parentheses or GCF parentheses. And they're going to be equal to 0. In order to solve, it needs to look like this, because that allows you to either have A equal to 0 or B equal to 0. So the bottom line is, before you start factoring, get it equal to 0 first, and that allows us to apply our solving technique when our quadratics are in factored form. So in this first example, x squared minus 4x equals 12. Well, I see equals 12. It needs to be equal to 0. So what I'm going to do is I'm going to subtract 12 from the right side and the left side, which gives me x squared minus 4x minus 12. Now this is a trinomial. There is no GCF. It's a trinomial where A equals 1. And so that means we can use our product and sum technique. Your product is negative 12, and your sum is negative 4. So you want two numbers that multiply to give you negative 12 and add to give you negative 4. So that would be negative 6 and positive 2. And so you set up your factors. X minus 6, x plus 2 equals 0. And now we have it in factored form. So this is our factored form that we want. And we've already learned, in order to solve in factored form, what you want to do is take each factor, x minus 6, and set equal to 0. X plus 2, set it equal to 0. So you would add 6, x equals 6. You would subtract 2, x equals negative 2. And so your final answer is x equals positive 6 or negative 2. So we get our factored form first, and then set each factor equal to 0 and solve. But bottom line is, make sure the original equation is equal to 0 before you move on. So if I look at example number 5, I have x squared plus 10x plus 25 equals 0. So I'm already set. I have the equals 0. I don't need to move anything from one side to the other. So I'm going to go right into factoring from here. I take a look. There is no GCF between all three terms. So I see 3 terms. That means you have a trinomial. It starts with x squared, which means your leading coefficient A is 1. So again, I can use a product and sum technique. My product is 25, and my sum is 10. So you want two factors of 25 that add up to give you 10. Well, that's easy. That's 5 and 5. And so I have x positive 5, x plus 5 times x plus 5 equals 0. Now, you have to understand what you're writing down first. Don't just go from here. I'm going to set each factor equal to 0 and solve. You can. You're going to get the same answer, but always look at what you're doing. You have x plus 5. You have x plus 5. It's the same factor. So if you set the first one equal to 0, it's going to be the same thing as setting the second one equal to 0. If I take a look, it's the same factor being multiplied together. So that means you're actually just squaring that one factor. X plus 5 squared equals 0. So this is the completely factored and simplified form. So really, if I want to solve, I just have to set the 1 equal to 0. I just have to set x plus 5 equal to 0 and solve, and x equals negative 5. There's no point in setting the other one equal to 0 because it's the same exact thing. So x equals -5. Now, what's interesting about this is it does technically have two solutions. It's just the same number for both solutions. And there's something unique that happens graphically for this problem. We know that our solution, -5, x equals -5, represents our 0, our root. It's our x-intercept. But there's something unique since there's actually two of the same factors. There's two solutions of -5 technically. Look what happens when you graph it. If I go to y equals and type in x squared plus 10x plus 25, and I hit graph, check out what happens when you hit that solution of -5 that we've seen before. That's your x-intercept of -5. Notice what happens on your graph. It comes down, it comes down, it comes down. It hits that point, and it bounces up. We call that a double root, a double solution, a double x-intercept, but it's referred to as a double root. It means that answer actually does occur twice. When you see on the graph that it bounces off that point and it goes back in the other direction, that means that answer of -5 actually occurred 2 times. So it's a way to connect, visual aspects of the graph to the solutions. Is if you see it come down and hit the x-axis and bounce back in the direction it came from, that means, hey, that x-intercept, that solution, that occurred twice in the quadratic. So try and make connections in that way. Let's see, I find that pretty cool that you can see the x-intercepts graphically, and you know based off of different things that are happening, if it bounces off, it occurs twice. And you'll see the further we go on when we're examining polynomials, other aspects of the graph can help you realize how many times solutions occur. So let's look at number 6. X squared minus 13x equals -36. What you want to do here, again, is you want to make sure it's equal to 0 first before you start factoring. So it's not equal to 0, so I need to make it equal to 0. So I'm going to add 36. There is no GCF in all three terms, so this is a trinomial. It starts with x squared, which means your a is 1. So we can apply our product and sum technique. Your product is your 36, and your sum is -13. So you want two numbers that multiply to give you 36 and add to give you -13. So that means they're both negative. So -9 times -4 is 36. -9 plus -4 is -13. So we write it down. We have x minus 9. We have x minus 4 equals 0. That is our factored form. Set each factor equal to 0 and solve x minus 9 equals 0. You would add 9. So x equals 9. X minus 4 equals 0. You would add 4. X equals 4. So your solutions, which are your x-intercepts, which are your roots, which are your zeros, are x equals 9 or 4. So in all of these examples, we had to make sure they were equal to 0 first, but if you were to go back, all of the factoring techniques used in this video was the trinomial method of a equals 1, the product and sum technique. So in this video, we focused on just that factoring technique. In the other videos, we're going to focus on some of the other ones that we've used in our factoring review.